Till now we have concentrated on introduction part as well as Newton's law of gravitation. Remember, gravitational force is always which type of force? One of the important question, attractive force. So with that basic information we can happily launch on second concept, concept 2, with the title Gravitational Field Intensity or intensity of gravitational field or gravitational field strength. Gravitational field strength means what is my strength in learning the subject, or what is my strength in approaching in facing any difficult task. So that meanwhile whenever there is a massive body, till what extent it can influence others, nothing but which is linked up with the field. For that field there will be some intensity definitely. Let us discuss the definition of this title first, gravitational field intensity. So gravitational field intensity at a point in the gravitational field is explained by the gravitational force experienced by a unit mass. So we are confining, we are specifying, we are concentrating at one point. Let us see once again, gravitational field, definitely every massive body tries to attract another body with a force called as gravitational force. Without having the existence of field we can't expect all these result. So what is the intensity of such a field of a force exerted by a massive body? That what is covered under this, will cover under this title. So the definition is, gravitational field intensity, gravitational field intensity at a point in the field is explained by gravitational force experienced by a unit mass placed at that point. So we are concentrating at a point. How it is explained by gravitational force experienced by a unit mass, means whose mass value is 1 kg. As a reference we are doing this. Gravitational force experienced by unit mass means whose mass value is 1, value of mass is 1 kg placed at that point. So this is what is called as the statement or the meaning or the definition of this gravitational field intensity. Let us imagine here is an gravitational field in any direction. I have fixed a point, I have taken a point whose mass is 1 kg, which is present in the gravitational field, GF in the sense gravitational field. Now definitely because of this field, why? Because this is the field that existed due to masses. So definitely this field is due to one large massive body like Earth if you take. Definitely this is also another massive body of mass 1 kg. These two will interact definitely. So that interaction leads in the form of force. So definitely this gravitational force or field exerts some force on this 1 kg mass, whose mass is 1 kg. That what we are calling it as gravitational field strength. So this shows clearly the intensity of the field of the Earth on the 1 kg mass. So this is also called as mass-mass interaction. So what we will call it as mass-mass interaction. Mass-mass interaction. So how can you represent the same symbolically? Symbolical representation is usually I is the notation, or E also you can use. I's formula is force experienced by a unit mass placed at a point. So vector by scalar, definitely we will get vector only. That's why electric field intensity or electric field strength is a vector quantity whose symbolical form is given as F by m. And we know as per Newton's law of gravitation or universal gravitation or universal law of gravitation, F formula is G capital M small m by r square. Already m is given here. So, for the purpose of F, what I have substituted Gmm by r square. M is already present here. Get cancelled. Finally, we left with Gm by r square. So, in the very next concept, concept 3, we will establish a relation between small g and capital G. So, this value will get it as small g. This value will get it as small g. Now, what is your answer regarding this relation, or the conclusion of this small derivation is I directly depends on acceleration due to gravity. That means, if more is the value of g, more is the value of I. So, I directly depends on small g. What about SI unit of gravitational field intensity? SI unit, by seeing the formula we can decide. For force Newton for mass kg. Meanwhile, what is CGS unit of I? CS unit is dyne by gram, And what about the direction of this I? It is in the direction of, no, it is always opposite to the direction of source of field. It is always opposite to the direction of source of field. Okay? Or else, to get clarity regarding the magnitude and direction, we have to see the important information regarding this I. So, representation of I. Next task is representation of I. Before going to the same, I will repeat it once again. Definition of gravitational field intensity is gravitational field intensity at a point in the field is explained by gravitational force experienced by unit mass, F by m, simply to say, with a neat diagram. And remember, this is the mass-mass interaction. I is F by m. In the next concept, we are going to learn, already I proved this. I proved this in the first concept. F is Gmm by r square. Already m is present here. Get cancelled. We left this Gm by r square. In the coming concept, third concept, we will establish relation, that is Gg relation. Gm by r square is nothing but small g. So, from this I proportional to small g. So, that what if the value of g is more, I is more. Then SI unit is Newton by kg. CS unit of I is dyne by gram. Next, representation of this I. How to represent this I? Representation of I. Representation of I. So, what is the magnitude of I? Just now I said that it is a vector quantity. Vector quantity means definitely it should have two qualifications. One is magnitude and another one is direction. One is magnitude and another one is direction. So, magnitude is nothing but, as per the formula you can conclude that magnitude of I is nothing but force experienced on unit mass placed at that point. If you take any gravitational field, a particle of mass or a body of mass 1 kg is present, force experienced on that or by that unit mass in that gravitational fields is called as magnitude. What about direction? So, here the direction of I is nothing but the direction in which a unit mass is allowed freely to travel. So, what is the direction of I means? It is the direction of a unit mass. Direction of I is nothing but direction of unit mass in which direction it is allowed to fall over. Or else we can also find the direction of I with gravitational field lines. We can also magnitude, defining magnitude is easy, but there is little bit trouble with the direction of this gravitational field intensity, that is I. So what is the alternate method? Alternate method to know the direction of I is simple. We know about gravitational field lines. Gravitational field lines. We have to remember that gravitational field line. What is meant by field line? Line of force. Line of force is nothing but it is the track that comes out or trace out, or the path that traced out due to force experienced by a unit mass. Track or path traced out whenever a unit mass is experienced by a force, whenever a unit mass experienced by a force, whenever it kept in a field, so which is called as line of force. Then based on this line of force, how about gravitational force direction? Gravitational force is directed, nothing but gravitational force direction is nothing but tangent drawn to the gravitational force direction is nothing but tangent drawn to the gravitational line of force at that instant. To know the direction of gravitational force, we should draw a tangent to the line of force at that instant. So finally, I can conclude this gravitational field intensity or gravitational field strength with one important point. That conclusion is, as we know that Earth is spherical in shape, and how the value of I varies outside the Earth as well as inside the Earth. Outside the Earth is inversely proportional to r square. For example, if a point mass is at a distance of r from the outside, this is inside of the Earth, outside and inside of the Earth. Let us take this is r plane, this is r, both are r. For example, intensity, gravitational field intensity from the surface of the Earth, a point exists outside the Earth. So how I and r are related means I inversely proportional to square of the separation, distance. Next, this is outside object. What about inside object? For inside object, I proportional to r only. And another conclusion, important point is line of force, gravitational line of force is normal. Gravitational line of force is always normal to the surface. Line of force is normal to the surface. Surface of mass, nothing but mass. Surface of mass. Okay, these lines of force are not always straight. These lines of force are not always straight. Yes, in the presence of two or more masses are present, these lines of force will be curved ones. If two or more masses present, then lines of force are curved. Lines of force are curved ones. Lines of forces are curved ones. This is the information regarding second concept. So in the second concept, we started with the definition of I, that is gravitational field intensity. It is represented usually I. In some books, I found that it is also with E. After definition, we had gone through small derivation and SI units, CGS units, and representation of I, and magnitude wise, direction wise. Again, for representation of direction, we follow two methods. And the first method is nothing but the direction of the unit mass in which that unit mass fall freely. allowed to fall. Next alternate method is by using gravitational field lines concept. So the conclusion is lines of force are always normal to the surface if it is a single mass. If there are two or more number of masses, lines of force, gravitational lines of force are curved ones. Okay. To know the gravitational force direction, draw a tangent to a line of force at that instant, that gives the gravitational force direction. So this is regarding which is a vector quantity, and regarding first concept and second concept, still now two concepts we have completed. In the first concept, it is purely about G, and remember capital G dimensional formula. Dimensional formula of capital G, which should be covered in the first concept, is dimensional formula of G is m power minus 1 L cube T power minus 2. Very important point, which should be covered in first concept. Dimensional formula of G is m power minus 1 L cube T power minus 2. And this rest of the part, third concept, will start soon. So this is the information regarding second concept, and thank you.